My name is Tim Lynch. I am an applications engineer for PITTMAN Motors. In this session, I will take a few minutes to discuss the selection of bearings for servo motor applications. When specifying a motor or gear motor, it is important to select the bearing type that is best suited to the application. Sleeve and ball bearings are the two common types of bearings used in subfractional horsepower, DC servo motors, and gear motors. Sleeve bearings are made of a porous, sintered powdered metal such as bronze that is impregnated with oil for lubrication. Ball bearings consist of a group of precision steel balls contained by a metal cage between inner and outer rings made of hardened chrome alloy steel or 440 stainless steel for corrosion resistance. A supply of grease inside the ball bearing provides lubrication throughout its lifetime. Metal shields retain the grease and keep out debris. Optional elastomer seals generally protect the grease better, but will also have higher torque and typically cost more as well. Let's review the selection criteria and compare the strengths and weakness of sleeve and ball bearings. Sleeve bearings are more economical. They are typically used in low duty cycle or low speed applications. Sleeve bearings are often the standard feature in brush motors, which have a commutator and brushes that tend to wear out. They may also be a standard feature in gearboxes, which naturally operate at low speeds. Ball bearings are more durable since they are made of stronger material and contain more lubrication. They are better suited to high-duty cycle or high-speed applications. Ball bearings are typically used in brushless servo motors, where longevity is normally limited only by the bearing life. Ball bearings should be used when side loads will be applied to the shaft of a motor or gearbox. For example, a shaft with a pulley subjected to belt tension. Ball bearings should be used when axial loads will be applied to the shaft of a motor or gearbox. For example, a shaft with a worm gear or lead screw. Motor shafts will have less free end play when used with ball bearings that are preloaded. This may be required when using encoder feedback devices that cannot tolerate much axial or radial movements. Sleeve bearings are quieter at low speed. Ball bearings, when preloaded to remove end play, are usually quieter at higher speeds. Ball bearings, when lubricated with the proper type of grease, will require less starting torque in extreme low temperatures.